Okay, hello. So we're still on integration by parts. So this time around, so we have two additional examples. However, those two examples has or examples have new approach. Okay, so in using the formula for the integration by parts, there are cases that so integration by parts can be applied multiple times. Like for example, if we use the formula and then we integrated, remember that we have the uv, then minus the integral of v du. So there are cases that the integral of the v du so can be integrated using integration by parts again. Okay, so in those cases, so there is a repetition on the process, and thus once once there's a repetition on the process, and then the answer recurs again and again, okay, so which resembles the original integrand, then that is the time that we're going to transpose it to the left hand side of the equation so as to combine it. Okay, so to illustrate that one, so we have similar examples just like this. So we have the integral of sine 3x cosine 3x dx. Although before, so we covered this one, so using two different angles. Okay, so the product of sine and cosine using two different angles, so which can be solved on that way. But alternatively, so we can use integration by parts in solving this one as well. Okay, so to start with, so we will be designating sine x so to be our u, and then the cosine 5x dx so will become our dv. So in such a way that u is sine 3x, then our dv it's cosine 5x dx. And then so we derive sine 3x, so its derivative is cosine 3x. And then the derivative of 3x, it's 3. So I'll just write it at the to be the coefficient. So 3 dx. And then for v, so we integrate dv. So the integral of cosine 5x dx, it's sine 5x. However, so once we derive 5x, that is 5 dx, so we need the neutralizing factor. So the neutralizing factor is 1 over 5. So we'll just have our v, so to be 1 over 5 or 1/5 of sine 5x. And then applying our formula, so to be uv minus the integral of v du. So thus, the integral of sine 3x cosine 5x dx, that is equals to u. So our u is sine 3x. And then our v, it's 1/5 sine 5x. So I'll start it with a 1/5, then sine 5x, then minus the integral of v, so which is 1/5. Okay, so 1/5 of sine 5x, our du is 3 cosine 3x. So 3 times 1/5, so we'll have 3 over 5. And then I'll start with cosine 3x, then sine 5x dx. So this is our v du. So multiply v and du. So that is 1/5 sine 5x, so times 3 cosine 3x dx. So that makes it 3 times 1/5 as 3 over 5. Then I'll start with cosine 3x, multiplied it with sine 5x. Okay. So that is our first try of the integration by parts. But then looking at the integral, so the integral there, so it just became cosine 3x sine 5x. Okay, so it's somehow it's it has the same format as the original integrand. Okay, this time around, so instead of sine 3x, it becomes cosine 3x, and then the cosine 5x, it becomes sine 5x. So in this case, there's no direct integral to that unless you use the cases or that will be case 3 for the transformation of trigo functions. But then in those cases that there is a possibility that it will go back to the original integrand, so we can reapply integration by parts. But of course, in this case, it's just the integrand. Okay, so that is in this case that is the negative 3/5 cosine 3x sine 5x. So for our second integration by parts, so I'll just have u, so to be equivalent to cosine 3x, and then our dv, so will be this time, so sine 5x dx. So the derivative of this, so cosine will be negative, and then cosine 3x, so derivative of 3x, that is 3 dx. And then for the integral, so the integral of sine, it's negative cosine, so negative cosine of 5x. And then the neutralizing factor will be 1/5. So now we apply the same formula. So I'll rewrite this one. So sine 3x cosine 5x dx. And then I'll have 1/5 sine 3x sine 5x, then minus 3/5, then multiply it with reapplication of the integration by parts formula. So I'll start with u and v. So uv, so that will be negative 1/5. And then I'll start with cosine 3x, and then cosine 5x. Okay, so uv, so negative 1/5 cosine 3x and cosine 5x. And then afterwards, so I'll just have the minus and the integral of v du. So we multiply the v and the du. So that will be, I'll start with the coefficient. So negative 3, so multiply it with negative 1/5. That makes it positive. Okay, so positive 3/5. Okay, so positive 3/5. However, we still have the negative there because that's the formula. Okay, so the formula is negative. And then the v du, that is the negative and negative, so that makes it positive. And positive times the negative, that would still be negative 3/5. And then afterwards, so we will be multiplying, okay. I'm sorry. So this should be sine. The negative 3 sine 3x dx. And then, so sine 3x, so v du, so sine 3x times cosine 5x. So sine 3x cosine 5x dx. And let's see. So sine 3x cosine 5x dx then is equivalent to, so 1/5. So sine 3x sine 5x, the negative and negative, so positive 3/25 cosine 3x cosine 5x. And then negative 3/5 and negative 3/5, that will become positive 9/25. Okay, so negative and negative, so positive 9/25. Then the integral of sine 3x cosine 5x dx. So what happens this time? So we have, okay, so positive 9/25, the integral of sine 3x cosine 5x dx. Actually, we cannot integrate that one right away again. Okay, so the integral of sine 3x cosine 5x dx. But this time, so looking at this integrand, so this one, and the original integrand, those are the same. So those are the same. The only difference is the numerical coefficient. The numerical coefficient of this is 1, and then the other one is 9 over 25. Okay, so it's 9 all over 25. So therefore, instead of doing the integration by parts again, because if we're going to do the integration by parts again, we'll go back here. And then do it again, we'll go back here. And then until such time that, okay, there will be a looping, okay? So that is happening, okay? So there's no end to that one. So what we're going to do is, so instead of doing that, so we can transpose, okay? So we can transpose the 9 over 25, so it will become, so this one, I'll just have 1, the integral of sine 3x cosine 5x dx. Then the other one would become minus 9 over 25, the integral of sine 3x cosine 5x dx would be equal to 1 over 5 sine 3x sine 5x, then plus 3 all over 25 cosine 3x cosine 5x, and plus c, because that's the end of it. We just need to combine the coefficient here. So since the two are just the same, okay, so the two integrand are just the same. It's just the coefficient which is different. So what we're going to do, so we can factor that out. So that is 1 minus 9 all over 25. Then the integral of sine 3x cosine 5x dx is equals to 1 over 5. So sine 3x sine 5x plus 3 all over 25 cosine 3x cosine 5x plus c. So combining the two, so that is the LCD of that. So it will be 25. So 25 minus 9. And then I'll just copy this one. So 25 minus 9. I'll have it as 16. Right? So 16 all over 25. And then, but then what we need to get is just the integral of sine 3x cosine 5x dx. So we need to remove the coefficient. So what I'm going to do is I'll be dividing everything by 16 all over 25. We're dividing this one by 16 all over 25. And what happens, I'll just have the integral of sine 3x cosine 5x dx will be equal to, so 1 over 5. So since this is division, so we can multiply this one by its reciprocal. That would be multiplied with 25 all over 16. And then sine 3x sine 5x. Then plus 3 all over 25, so multiply it with 25 all over 16. Then cosine 3x cosine 5x plus c. C over 16 over 25 is still c. So therefore, the integral of sine 3x cosine 5x dx, so 25 and 5, so we'll retain 5 all over 16. Okay, so sine 3x sine 5x. 25 and 25 would be cancelled out. So that would be plus 3 all over 16 cosine 3x cosine 5x plus c. So that will be our final answer then. So 5 over 16, so sine 3x sine 5x plus 3 over 16 cosine 3x cosine 5x plus c. Okay, so that's how we do transposition if the integral part of the integration by parts, or the VDU part of the integration by parts, recurs, okay, or it repeats similar to that of the format of the original integrand. Okay. So let's continue with example number 8. So example number 8, so we have the integral of secant cube 2x dx. So this is another case in transformation. So that will be under case 5. Okay. But remember in case 5, so when the exponent is add, okay, so we skip that one. So it's because that one can be solved using integration by parts. So again, so we transform this one into a format which is integrable. So that would be secant 2x, and then the other one would be secant squared 2x dx. Okay, so we have secant 2x, the other one is secant squared 2x dx. So the problem with this is we have the secant squared 2x dx. So that could be our differential. However, it is multiplied to secant. So the derivative of secant, it's secant tangent. But if it is actually tangent, so right away, so we can use the power rule. Say derivative and tangent is secant squared. But we cannot do that one here. But instead, so we can use integration by parts. So we're going to let u go to be the secant 2x. Then our dv, so which is the secant squared 2x dx. So secant 2x, then dv is secant squared 2x. So we derive secant 2x, that would be secant u, secant 2x, tangent u, tangent 2x, then 2 dx. So I'll just write the 2 here, and then I'll have the x there. So for the secant squared 2x, so secant squared has a direct integral, so which is tangent, right? So it's tangent 2x. But then, so we have 2x there, so we need a neutralizing factor of 1/2. Okay, so we have v then to be equivalent to 1/2 tangent 2x. So now, so we can employ our formula, that is uv minus the integral of v du. That's our u. It's secant 2x, v is 1/2 tangent 2x, so multiplying these two, so that is 1/2. I'll start with secant, so secant 2x tangent 2x. So that is the integral of secant cube 2x dx. So that is our uv. Then minus v du. So v du, so this one and this. So 1/2 and 2, that would just be 1. And then secant 2x, tangent 2x times tangent 2x, that is tangent squared. So I have secant squared or secant 2x, then multiply it with tangent squared 2x dx. Okay, so secant 2x and tangent squared 2x dx. So next, we cannot integrate this one right away because the, let's say, kung power siya ng secant, its derivative should be secant tangent. So we don't have secant tangent. If it is tangent naman, that should be secant squared. So kulang pa rin siya, no? But then, I can use some identity here. The identity will be, so I'll just rewrite the original integrand. So 1/2, so secant 2x, tangent 2x, and minus secant 2x. So tangent squared has an identity, so that is secant secant squared 2x minus 1 and dx. So the secant cube 2x dx then is equals to 1/2, so secant 2x tangent 2x. Then minus, I'll distribute. I'm going to multiply this one here. So negative times secant and secant squared. So minus secant cube 2x dx. Then the negative secant multiplied with the negative 1. So that would become plus the integral of secant 2x dx. Okay. So what happens this time? So this one, so the secant 2x has a direct integral. Okay, so we just need to let u as 2x, so our neutralizing factor is 1/2. However, for the secant cube, so there's a repetition. Okay, so that happens. So the secant cube 2x recurs again. But then, this one and this are the same. So similar with what I did on the previous example. So I'm just going to transpose that. Okay, so secant cube 2x dx, and then I'm going to transpose this one here. So that would be, it will become plus secant cube 2x dx, and that will be equal to 1/2. So secant 2x tangent 2x. So in here, our u it's 2x, so du it's 2 dx. So therefore, our neutralizing factor is just 1/2. Just simply plus 1/2, and then the integral of secant, that is ln of secant 2x plus tangent 2x, and of course d plus c. So combining the two, so we'll just have 1 and 1. So it has 1 here, it has 1 there, so therefore that's just 2. So 2 integral of secant cube 2x dx will be equal to 1/2, then secant 2x tangent 2x plus 1/2 ln of secant 2x plus tangent 2x plus c. And we divide everything by 2. So therefore, the integral of secant cube 2x dx is equals to 1/2 divides 2, that is 1/4. Okay, so 1/4 secant 2x tangent 2x plus 1/4 ln of secant 2x plus tangent 2x plus c. And that will be the final answer. And that's the additional technique, okay, so that we can do for integration by parts. Okay, so we just have to take a look at how the process takes on. Okay, so if there is a recurring integrand, so which is the same as that of the original integrand, then we can use the transposition. Okay. So if we have multiple application of integration by parts. So usually that is happening for integrals of trigo functions, or sometimes it's the product of exponential and trigo function, okay? So things like that. Except for products of whatever would be the function with an algebraic. Let's say if it is a product of whatever would be the function with algebraic, algebraic has termination or it's terminating. Okay, so because once we derive the algebraic, the end, multiple application of it, the end will be 0. Okay, so unlike with exponential, so once we derive it, that's forever exponential function. Okay, so there's no end to it. There will be no time that it will become 0. Okay, so only algebraic function, so which terminates to 0. So in cases like this, okay, so if the integrand keeps on recurring, and then it resembles the original integrand, then we can transpose it to the left-hand side. But if you transpose it, okay, and then it cancels out, I say in this case, it's negative, right? So that's why when I transpose it, it becomes positive. So they combine. There are cases that it becomes positive. Okay, this one is instead of negative, it's positive. So once you transpose it, it becomes negative. Then most of the time, so what you did there is you just interchange the u and the dv. So meaning it goes back to the original integrand or integrand. In that case, it is the process that you've done which is incorrect. Okay. Let's say, for example, in here, u is sine 3x and then dv is cosine 5x. And then if on the second, this one is sine, then this is cosine. And then on the second, if what you did here is instead of the cosine 3x, you make the cosine 5x as your u. And then instead of the sine 5x, so you make the dv as the sine 3x. So that there will be a time that it will just cancel out. Okay. So it's the process that is incorrect then. If the integrand which recurs, and then you transpose it to the left-hand side, and then it cancels out, there's something wrong on what you've done. Okay, so that will be all.